Today we are going to see what is a serial monitor. For this, first of all, you connect your Arduino to the laptop. Then you open Arduino software. You click here. This is serial monitor at the top right corner. You click it and a window gets open like this. This is serial monitor. Here we can send and receive messages to or from the Arduino. You can see the state of Arduino here. For example, if you write this program and you open the serial monitor, you will see hello world written here. Similarly, this is a program in which you are sending and receiving messages from the Arduino. This window is on the laptop. We can send any message to the Arduino. For example, if we write yes and press enter, LED on the Arduino will be on, and if you write if you write no and press enter, light will be off, and here it will tell you light is on, light is off, light is on, light is off. This is a brief introduction. Now let's see how we can simulate it. This is Arduino. Just take an LED. Okay. This is the negative side cathode. It will be grounded. Let's say connect it at pin 13. Okay, that's it. This is our circuit and it is complete. Now let's write the program. Okay, take text here. Okay, now delete this line. Just right here, now we have connected at pin 13, and where we connect an LED, that pin must be declared output. So pin mod 13 output, semicolon at the end, it is a must. After that, I start the serial monitor, serial.begin. It will begin at 9600. Just write this line, serial.begin 9600. It will activate the serial monitor. Okay. Then we can write serial dot print line. Here you can write serial started. Okay, delete these lines. Okay, I'm writing digital write 13 high. LED at pin 13 will be on. Then I write serial dot println, and I will write pin 13 is on, and just copy paste, Control C and V. Right here low, and pin 13 is off. And delay is important. Just put a delay here. Delay, let's say 2 seconds. 2 seconds mean 2000 milliseconds. Okay, just copy and paste it here. Now what this program will do, first of all, it will make pin 13 output, then it will begin the serial monitor, that line is must, and then it will print serial started. Okay, and then we will enter the loop. When pin 13 will be high, it will print pin 13 is on. That means when this pin is high, Arduino sends a message to the laptop that this pin is on now, and when it is off, Arduino again sends a message that this pin is off. Now let's run and see how it works. Okay, now here is serial monitor. Open it. Now see, serial started. When pin is on, it will write pin is on. When pin is off, it will write pin is off now. So we can see whatever status of the Arduino is on the serial monitor. Okay. Now let's say if there is no LED, I turned off LED. Now I don't know when pin 13 is off or when it is on. But when I simulate, I can read on my laptop that this is on or off. Now see, right now it is on and now it is off. So this is one-way communication. Arduino is sending message to the laptop that what is going on in the Arduino. It is telling the laptop. We can read it on our laptop. Okay, let's clear it. Now let's see how we can send message from laptop to the Arduino. Okay, I'm going to write a computer. I will command the Arduino that open this LED, on this LED or turn off this LED, etc. Okay. Okay, connect an LED again. Let's say it is at 13. Okay. I am going to write a program. I will send a message to the Arduino from my laptop that turn on this LED or turn off the LED. For that, first of all, I need to declare a variable character X, and that's it. Then move inside the loop and right here if serial dot available is greater than 0. That means if there is a byte to receive or if there is something to receive at the serial port, then what to do? It will enter inside the if loop. Okay, and then we will read X is equal to serial dot read. That means whatever we have sent from the laptop, Arduino will read it. Okay, I will explain further. Now see, if X is equal to A, character we always write in these inverted commas, single inverted commas. Okay, and if it is A, digital write 13 high. That means if I send A, light should be on. Okay, and then it write print serial dot print ln. Here we can write 13 is on, and just copy paste this line here and right here B. If I send B, light should be off, low, and here we write it is off. Okay, now what this program is going to do, we will send A or B and light will be turned on or off. Let's see. Okay, error, spelling mistake, serial. Okay then. This is serial monitor. It has printed this message. Serial has started. Okay, now if I write okay, if I write A, this line will be it will be executed. That means LED will be off and it will print 13 is on. Okay, let's see. I am sending A. I write A and I press enter. Now see, LED is on and it has written that 13 is on. So now Arduino and laptop are talking to each other. Laptop asked Arduino to turn on the LED. It turned on the LED and sent back the message to the laptop that 13 is on. Now let's say I enter B. It will turn off the LED and print the message also. Now see, LED is off and it has told us that 13 is off now. Okay, now let's improve this program. Okay, I'm connecting another LED here. let's say it is connected at 12. Okay, and one more LED. Cathode is always grounded, and this is connected at 11, and one more LED here. Cathode grounded as usual, and okay. Now I've connected 4 LED. Change their colors. Let's make it blue, green. Okay, make it green, RGB. Green, this will be blue, and yellow. Okay, now I'm going to write a program that we can turn on of any of these LEDs. Okay, let's say I write R for red. So 13 will be on, and I will print here red is on. And for blue I will use B. No, sorry, for green I will use G. When I send G, 12 will be on, and it will write here green is on. Okay, and okay, it should be high. Just copy paste this and add 2 more ifs. Okay, okay. G then B. If B, then 11 will be high because blue is connected at 11, and I will write here blue is on. Then there will be 10, and at 10 we have connected yellow, so I will write Y for yellow, and it will write yellow is on. And very important, we need to declare all of them output. If you don't declare, they will not be on. Okay. So 13, 12 and 10. 13, 12, 11 and 10. They are output. Okay, now let's see. Okay. Open serial monitor. Now if I okay, clear it. If I write B, it will turn on blue light. I enter B, enter. Now see, blue is on. If I write Y, Y means yellow, enter, Y is on. If I write R, red is on. If I write G, enter, green is on. It is turning on all the lights, and it is also printing the message on the laptop that this LED is on. Okay, now let's add some method to turn them off. Okay, just put some other if. Okay, I put an if X is F. F means off. Off means all should be low. Okay, just paste it for 3 more times. So 13, 12, 11, 10 all low, and here we should write all LEDs off. Now if I send F, all LEDs will be off. And similarly you can add another if, and you can as many ifs as you like. You can create your own patterns. Okay, if I enter A for all, that means all on. Okay, 13 high, 12 high, 11 high and 10 high, all LEDs on. Okay, now see, these are the codes we have created. R for red, G for green, B for blue, Y for yellow, F for all off, A for all on. Okay. Okay, clear. Now if I enter A, I send the message A to the Arduino, and I'm telling the Arduino that turn on all LEDs. A, enter. All LEDs are on. If I press, and it also printed all LEDs on. If I enter if, all off. Then again Y, yellow. If I enter red, and if I enter G, green will be on. And that's it. So this is how laptop and Arduino talk to each other. Now you can connect your room lights or home appliances instead of these lights, and you can turn on of them using your laptop. Okay. For example, you write F, you enter F, fan is on, you enter B, bulb is on, you enter B2, other bulb is on, and if you write W, washing machine is on. So in this way, you can send and receive messages to the Arduino.